It's been a long week. Hey everyone, welcome to the Coding Zoo. Man, it's been a long week. If this is your first time joining, my name is Shane, and the Coding Zoo is here to help others learn how to program. This is our JavaScript building block series where we go over one or two features, one video at a time. So this is lesson number 23. In this lesson, we're going to cover how to create objects. So JavaScript is a functional and object-oriented type language. It supports both programming paradigms. We are going to cover in this lesson how to create objects with constructor functions and with object literals, followed by next lesson us covering ES6 objects. Very cool stuff. So hey, if that interests you, click the subscribe button. If you like the video at the end, go ahead and click that like button. And if you're ready to get started, let's go ahead and jump in. Hey, okay, so before we get started, we probably should cover what an object is. An object in object-oriented programming is basically a data structure that has both properties, has data that describes a particular real-world object. For example, if I have data around a car, let's say I have a system that maintains data on a car. Well, I'd represent a certain type of car with a car object. And that car object would have properties. For example, it may have wheel size. The wheel size would be a property. That car object may also have not only properties that describe it, but it also may have operations or behavior method. That's kind of where object-oriented programming came from. It's about thinking about the computer programming from a real-world perspective. Let's go ahead and jump into the code. So I have on my desktop here, as usual, I have my main.js and I have an index.html file that includes that main.js. I went ahead and wrote the code this time to make the lesson go by quicker. I definitely recommend that you stop the video at times and code what I'm coding if you have time. If not, you can download the code from our website. We usually have the code out there within a week or two of posting the video. So in my main.js, I have created what's called an object literal. So I used constant to define an automobile, right? So constants, ES6 way of creating constants. If you're not using ES6, you can always use var. All right, so I've got constant automobile, open squiggly bracket, and I've got a close squiggly bracket down here. And then I have year, which is a property. I'm defining a property there. I've got colon. And then I have a number for a value, 2016. I could have made that a string also. So I have name, colon, value, comma, and then I put another property, name, colon, value, comma, and then you put another property. So the second property is called model, and the value is charger. And then the next property is called make. I've got make, colon, and then the value Dodge. So that's how you create properties on object literal. So object literals are good ways of creating. So object literals are good ways of creating object if you're only going to use one instance of that object. It's quick, it's easy, it's very simple. If you're only going to use one instance of it, definitely the way to go. You can create multiple instances of an object literal. I'll show you how to do that in a minute, but probably not the best way to do it. I have these properties on the automobile, and if you look at the bottom here, I have a start engine. So again, I have name, colon, and then I define a function. So these properties, year, model, make, they describe my real-world object, an automobile, and the start engine, the function or method, it's really a method on an object, actually performs business logic, performs behavior. So in this case, I'm just returning vroom or vroom, however you say that, vroom, something like that. In a bigger system where I'm performing a lot of business logic, I may take certain properties and perform calculations and do certain things with those properties. Right? You have behavior. Kind of important to remember that even though you're in an object-oriented language, you're using objects, you may not always be doing object-oriented programming. It's very common for us to create objects and only have properties on them. That's not a true object. An object has properties and behavior. So the business logic should be stored on the object, not in some service class or something like that. Okay, so here's my automobile object literal. I'm going to go ahead and run this real quick. I'm going to uncomment document write, and I'm going to show you how I access that object. So I do document write, the object name, the constant, and the property. And then I do document write, the object name, the variable name for it, and start engine to perform the behavior. Click save, click refresh. There we go. So it was able to read the object and print out the name, or rather the model, and it was able to call the behavior vroom to start the engine. So pretty simple. All right, so let me show you real quick kind of a downside of using object literal. Now let's say I wanted to have a property on this object that was made from the other properties on this object. Let's say I wanted to have a name, and the value I wanted to be this object's make and this object's model. Well, I think if I do that, I don't think it's going to work. Nope, it basically errored out. So if I go back here, so this is one thing that's not allowed in object literal that is allowed in the other ways that I'm going to show you how to create an object. Okay, erase that. Now I can't create a property that way that references other properties, but you can, after the fact, add on that property. It's just not as clean. So for example, if I do this, this should work. It's going to create a name. Here, let me print out the name real quick. I'm going to cut and paste to save time. And let's print out the name. There we go. Let's see if that works. Click refresh. There we go. So that was one way you could do that. Again, that's not very clean. It's kind of outside the declaration of that document literal. So I kind of dislike it when it's outside. It's not kind of cohesive in my opinion. It's not, yeah, anyway. Object literals are great when you want to create one instance of an object and pass it around, one instance of a set of data and pass it around. You can create multiple instances of that same data. It's not very clean. I don't recommend it, but I'm going to show you just in case you have a need for it at some time for whatever reason. All right, so I'm going to go here and uncomment this code. So here I have a Ram truck constant. So I created an automobile up here. The automobile is a Dodge Charger. That's what it represents. Here I want to create an automobile. So I'm going to take that constant automobile, which points to that object literal, and I'm going to use object.create, which is built into JavaScript, to create a new instance of that object literal. And I'm going to put it into the variable Ram truck. Once I've created a new instance, I can then go ahead and change the properties to represent something else. So the original automobile properties will represent what they originally represented, which was Dodge Charger, and the new one would represent whatever I set it to. So here I'm setting a Ram truck, and here I'm creating another one, and I'm setting a moped, and you'll notice they both work at the same time. So I basically have 3 different automobile objects here. Let's run that. So there we go. I have the Charger doing the vroom. I have the Ram doing the vroom, and I have a mopeds doing a sputter. So there we go. So there is a way to create multiple objects from an object literal, but not the cleanest thing in the world. Definitely wouldn't recommend it unless there's some special case for it that I am not aware of. Let's move on. There is another way of creating objects. It's very similar to object literal. It's basically the same thing. And again, you're basically creating a constant and putting properties and functions on that constant. You're doing it outside the instantiation of that object. If I had to choose between these 2 ways of creating objects, I would definitely choose document literal. It's just cleaner, much easier to use. One way, instead of doing object literal, is to say constant automobile 2 in this case, equals new object. So I just created a new base object in JavaScript. So this object class is kind of built in. This object function is kind of built into JavaScript. And then once I have that object, I can dynamically add on properties to that object, right? So automobile 2 put a year. I do dot year to add a property. I can also use the array-like syntax with the brackets, and I can add a property that way. That's one good way of doing things dynamically at runtime, adding properties. That's pretty helpful in certain cases. And again, you can just add on the property just by doing dot in the name of the property. Okay, so I'm going to run this. I really don't like this way. To me, it's never been, I don't really use it, not that helpful, but hey, maybe I'm missing out on something. Maybe there's something I don't know about there. I probably wouldn't recommend it. I would use object literals. Let's click refresh. There we go. So I'm going to change the name of the charger to Challenger, just so we can make sure we're reading this correctly. There we go. Okay, so it was able to instantiate an object, and I was able to set the properties, set the behavior, and call the properties to read them and call the behavior. Again, my favorite of these scenarios here is object literal. I would recommend that. I use it quite often, especially when I'm just going to create an object once and pass it around, and I'm not creating multiple objects of the same type. Object literal is the way to go, in my opinion. All right, let's move down to a constructor function. Now, if I wanted to create a class or an object type that can be instantiated multiple times with different sets of data, for example, maybe I wanted to represent many cars, I prefer this way, or the ES6 class. This is called a constructor function. Basically, you create a function and you give it a name. Since it's going to be an object, you give it uppercase. Most functions you use camel case. So you start with a lowercase letter. In this case, since it's going to be an object, you use uppercase. So function car, and you basically have parameters that are being passed in that you're going to set the data on this object. You're going to construct the object with this data, constructor function. So then we do this.make equals make. So I'm setting the data that's passed in from this make variable to a new property on this object called make. You do that by saying this function, this object. All right. Do the same with model, year, and here you can see I can actually go ahead and create a property called name that adds those other two properties together. This will work in this case where it wouldn't work in the object literal. And then I add on a function to give it behavior. So very simple. Now, to instantiate that constructor function, you basically do assign a variable to new and then the name of the constructor function, in this case car, and I pass in these values, and then I document write it out, and then I come down here and I do the same thing for my truck, and I pass in different values, and both of these objects can exist at the same time in memory. This is a very clean way of creating multiple objects of the same object type. Let's go ahead and save it. Let's run it. There we go. So constructor functions. My car is a charger and my truck is a Ram. So I was able to use the constructor function to create two objects and access their properties. Very simple, very clean. In my mind, the way to go, or ES6 classes, when you want to have multiple instances of an object type with different sets of data in it. One thing to note here is, what if I wanted to add on behavior to my truck, but I didn't want to add on to my car? Or what if I wanted to add a property onto truck that I didn't want to add on to my car? Is that possible? It is possible. One way you can do that is simply just tack on the variable. So if I do my truck and the property tow capacity equals 3,000 pounds, then it's going to tack on that property dynamically at runtime, and it will have the property. My car won't have the property. So right here, I actually print out each of the properties in my truck, and I print out each of the properties in my car. I do this with a for in loop. Let's see what that looks like. So I'm going to save it. So I should have a new property on my truck rather. That's not on my car. There we go. So properties in my truck, make, model, year, name, start engine, tow capacity. So there it is. Now properties in my car, make, model, year, name, start engine, tow capacities, missing. Now if you go here and inspect your code and go to console, I did a console.log so we could see those two objects. You'll notice they're both called car because they're both made from the same constructor function. There's my Dodge Ram, there's my Dodge Charger, there's start engine. start engine, and there's the tow capacity, and then of course this one doesn't have one. So what if you wanted to add on a new property at runtime for certain circumstances to all of the car objects? Is that possible? Well, objects in JavaScript have prototype inheritance, or prototype. I sometimes get that messed up. So prototype inheritance, I believe, is the way to pronounce it. Prototype inheritance is basically it's using a pattern called prototype. If you've ever heard of the Gang of Four design patterns book, you can reference what that pattern is there. It's a very common pattern, it's been around for a long time. It basically says, hey, I've got an object, it's a blueprint, and I'm going to create other objects from that blueprint. It's a good way to deep copy an object and create new objects and change their data later to represent different things. It's a neat pattern. If you haven't studied it, check it out. Gang of Four design patterns. I can actually access a prototype property which is automatically added to these objects in JavaScript. So if you look here, I've got car prototype. So I'm accessing that prototype property, that main prototype that all cars are created from. And I'm adding press horn. Again, I loop through the properties. If that worked correctly, both of them should have a press horn property. Let's check it out. Save, refresh. There we go. So I've got car and car. And if you go down here to the bottom, here's press horn. There's press horn. So they both got the property added. You don't see it over here because I logged these out. I believe. Oh, there it is. Press horn, added onto the prototype. So there we go. That's a way that even after the objects are instantiated, you can still add on methods or properties that can be used by all instances of that given object. Let's move on. What's the benefit of constructor function over object literal? Well, it's a lot cleaner, definitely a better syntax in my opinion. There are times, like I said, I use object literal a lot. I'm just going to create one instance of an object and that's it. If you're going to create multiple instances though, I'd recommend constructor function. Here's one thing that's really better about a constructor function. You can basically have closure. Now, closure is basically saying, hey, I'm going to hide the property's real data, the internal data. I'm going to hide it from outside by storing variables at this level and returning them at this level, right? So in an object-oriented world, usually you want the behavior and properties of a given object to be encapsulated. You want to hide as much as possible the implementation of your object from external calling code. That way, if you need to change it later, it's easier to change and you don't have to change 1,000 different places. So one of the benefits of object-oriented programming, if you do correctly, is you have that encapsulation and you can change business logic without having to break 100 different lines of code in the calling code where that object is called and used all over the place. And with some systems that can be quite a bit of change. I have a function here called computer. It takes in the name CPU. Now I take those variables and instead of doing this and assign it as a property, I just set these variables in this scope, right? Using var. You can use let also, and in ES6 I'd recommend that. So I have var CPU equals CPU, var name equals name. Now if I were to create an object called computer and then do that variable dot CPU, I won't be able to access this data like I could using this dot CPU. So that's kind of the benefit. I'm hiding these variables, and here I'm doing this dot get name and this dot CPU, and I'm assigning a function. This function is available to calling code, and this function will allow the calling code to get to those variables and read them, but the calling code cannot change those variables, right? And if I wanted to tack on more data here, well, since the calling code can't change those variables, it can't change the name, it can't change my formula, it can't mess up my business logic here of adding on this Mr., right? So this is a cleaner way of creating objects. It's more encapsulated. Let's check it out. Let's run it. So here I instantiate a new computer. I write out the properties. All right, so properties of computer. Well, the first one was undefined. So what was the first one? Well, I wrote out my computer.cpu. So remember I said it's hidden. You can't access it directly. That's what I mean. All right, then I have my computer get CPU, and that's what we see here with tiny. So tiny CPU. I could not remember the CPU type of Apple IIc. I guess I could have Googled it, but I got a little lazy making this. Never mind. All right, let's print out one more thing here. I'm going to print out the get name. All right, click save, refresh, and there we go, Mr. Apple IIc. Now if you go up here and look at computer, there we go, get CPU, get name. Those are the two functions that I exposed that you can get those that you can use to get the properties. Those are the two methods rather. Okay, so pretty simple. So in this lesson, we covered how to create objects using object literals, how to use constructor functions. We told you the difference in the two. We also showed you how another way of creating very similar structures to object literals. I don't necessarily recommend those. Object literals, constructor functions, and ES6 classes I think you'll use a lot. You may also use basically an object factory. We'll go over that in the future. But hopefully this makes sense. If you have any questions, definitely leave me a comment below. We're going to cover ES6 classes in the next lesson, so I hope you stick around and subscribe. You can do that at the bottom, and you'll be able to see that lesson in the next coming weeks. Hope you enjoyed this lesson. We'll see you next time.